Okay, so welcome to the Unit 2 Lesson 2 video on graphing quadratics in intercept form. So today's lesson's objectives, we will be graphing the quadratic functions when they're written in intercept form, and we'll also be writing some quadratic functions in intercept form by using the graphs and the characteristics. Alright, so kind of go in both directions. So intercept form, this is when a function is written f of x equals a parentheses x minus p times the quantity x minus q. That is intercept form, right? So basically we have two factors here. So that helps us to understand intercept form is also known as factored form. Right? So if we see two things being multiplied together, then it's going to be intercept form or factored form. Intercept form is named because it identifies the x-intercepts of the graph in much the same way as we call the vertex form, because it makes seeing the vertex very simple, right? So if we want to graph from intercept form, we still need to find the vertex because that key turning point is really important. So when we find it, it's a little bit different for intercept form. And we'll also find the x-intercepts. So let's take a look at how we would do that. Again, here's our factored form in general. And for simplicity's sake, let's make this function actually change that 5 to a 4. So it should say f of x equals x minus 4 times the quantity x plus 2. All right, and that'll make it much easier for us to work with. Okay, so we're going to be graphing now, and we're going to start actually over here on the x-intercepts, also known as the zeros. We'll talk a little bit more about that when we talk about solving, but realize x-intercepts and zeros are really talking about the same thing. All right, so if I have a graph and I have it in factored form, I know that I can set x minus p equal to 0 and x minus q equal to 0 based on the product property, right, to solve it. Right? When y is 0, then x will be p, or x will be q. So that means on my graph, right, these would be where I would cross the x-axis. So if I have x minus 4, right, if I set that equal to 0 and solve, I get x equals positive 4. If I do x plus 2 equals 0, I get x equals negative 2. So those are my zeros, which I can turn into x-intercepts by adding a comma 0 in parentheses. So I know that I have a point here at, we'll call that 4, 0. And I have one back here at negative 2, 0. Okay, so that's why we call it intercept form, because it basically just tells you what the intercepts are. Just remember that if it's in parentheses, it's the opposite. So x minus 4 becomes positive 4, x plus 2 becomes negative 2. So I have my x-intercept. I know where this line will cross the x-axis. Now, the other key important thing here to a graph of a quadratic function is that it has its axis of symmetry. The axis of symmetry states that the graph will reflect and fold onto each other. So I know that axis of symmetry has to be right in the middle. So to find the vertex, look for the axis of symmetry, which is located at the midpoint of the x-intercepts. So the midpoint is, add them up, negative 2 plus 4 divided by 2. And that gives me x equals 1. So I know that the x value of my vertex, right, my vertex has an x value of 1. So now I got to find the y value. Well, to find the y value given an x value, just plug it in. Find f of 1, and that is 1 minus 4 times 1 plus 2. So negative 3 times positive 3, or f of 1 equals 9. So now I know I have a vertex at 1, 9. So I could put that point right up here. We'll call this point 1, 9. And now I can graph it. And that is graphing from intercept form. All right, so let's do one more example, right? This one's a little trickier because it has a multiplier. So again, let's do the x-intercepts first. So I have one at -5, 0, and I have one at 3, 0. So let's find the vertex. -5 plus 3 over 2 gives me -2 over 2, which is -1. So plug that in. F of -1 equals 1/2 of -1 plus 5 times -1 minus 3, or 1/2 of 4 times -4, which is 2 times -4, which is -8. So I have a vertex of -1, -8. I now have 3 points. From those 3 points, I can graph. Let's go down here to -1, -8, -5, 0, and 3, 0. And that's all we need for graphing from intercept form. All right? So try this one on your own. Pause the video, give it a try, and then we'll come back and check your answer. Okay, so here should be the vertex, x-intercepts, and graphs of the function provided. Notice that this was a negative function, so it should be opening downward, which it is. All right. So that is graphing from intercept form. Pretty straightforward. Let's take a look now at writing equations given the following characteristics. All right. The first thing to realize is that my function is f of x equals a times x minus p times x minus q. All right? So, what does that mean? Well, I know that if I have an x-intercept of -6, then I know that this is x plus 6. And if I have an x-intercept of -2, I know that's x plus 2. All right? So, if I was to then realize that I have a vertex, right, we'll call this y equals a, right? So I still got 3 variables to deal with, but I have a vertex here, which happens to be an x and a y. So I can plug that in. -2 equals a times -4 plus 6 times -4 plus 2. So -2 equals a times 2 times -2. So -2 equals a times -4. Divide by -4. And I get 1/2 equals a. So now I can write my equation. F of x equals 1/2 the quantity x plus 6 times the quantity x plus 2. And there is my equation in intercept form given the vertex and the x-intercepts. Use the x-intercepts to find the factors. Use the vertex to work your way backwards to your a value. And then you can plug them all in. So pause the video and try number 2. Go ahead and pause the video and try number 2. Okay, so here's the answer for number 2. Hopefully you didn't find that to be too difficult. The last thing we're going to talk about here are writing the equation of the function given a graph. So we're just going to analyze the graph. What's our vertex? Be -1, 8. The x-intercepts are -3, 0, and 1, 0. So from the graph, it's actually even easier because you don't really even need to find a algebraically, right? If I'm looking at this, I know it goes down, so I know it's a negative a. If I move over 1 down 2, then I know that that is a stretch by a factor of 2, because it should be over 1 down 1, right? And then I can say x plus 3 and x minus 1. Now, if you're not comfortable with that, finding a by looking at the graph, you can always plug it in, right? 8 equals a times negative 1 plus 3 times negative 1 minus 1. So 8 equals a times 2 times negative 2. So divide by negative 4, and a equals negative 2. So again, if you're not comfortable just looking at the graph and figuring that out, do a little simple algebra and you should be able to get the correct answer. Alright, so hopefully this is not too difficult. So go ahead and attempt the last problem here and we'll see what you get. Pause the video, give it a try. Okay, so here's the equation that you need. If there's no a written in front of the parentheses, it is a positive 1. And I did some work over here in case you weren't comfortable going from the vertex over 1 up 1. We did the algebra to figure out a was 1. So that's pretty much it. It's pretty straightforward. I hope you found this lesson to be accessible. If you have any questions, we'll discuss it in class. Until then, make sure you get all your classwork and homework done on time. All right, have a good day.